Yes. So group 18 elements. Group 18 also known as inert gases. Inert gases also known as noble gases. Okay. Inert gases are noble gases. These are the last group in P block elements. Okay. Last group. Group 18 elements are the last group in P block elements, and also the elements present in this group are the last element in that period. If you check first period, helium is the last element. First, you just try to know which elements are present here in this group. Helium, neon, argon, krypton, xenon, and radon. After this, synthetic and man-made, that is ogneson, OZ. Ogneson. This is also radioactive element, but this is man-made synthetic element. Okay, these are all elements present in group 18 or 8th A group elements. We can also say these are all 8th A group elements. Okay, 8th A group elements, 8th A group elements. Okay, so if you go first period, helium is the last element in a first period. If you go to the second period, neon is the last element. If you go to third, argon is the last, fourth, krypton, fifth, okay, xenon, and sixth, radon, like that. Okay, all these elements are the last elements in that corresponding periods. Okay, so these are all monoatomic elements. These are all what? Monoatomic elements, and also these are all present in gaseous state. So we can call them as gases. Noble gases are monoatomic gases. Okay, and then their general electronic configuration, if you check, NS2 NP6. Their general electronic configuration is the NS2 NP6. Outermost shell of all these elements filled with the 8 electrons, that is completely filled outermost electronic configuration. That is the reason these are all having inert nature. That's why we can call them as inert gases, because of 8 electrons present in that outer shell of all these elements. All these elements are not going to participate in any chemical reaction. That's what we can call them as inert gases. Okay, and also noble gases. These are all available in atmosphere. These are all available in atmosphere by 1% volume, 1% by their volumes. 1% by their volumes, except xenon and radon are the rare availability in atmosphere, but helium, neon, argon, krypton, they can able to available in atmosphere. Among helium, neon, argon, krypton, argon is the most available element in atmosphere. After that, helium and neon are available in radioactive decay of pitchblende. Pitchblende, monazite, clevite. This is the radioactive decay. Okay, from this one, helium and sometime neon are going to be available. Okay, argon is the most available element in atmospheric conditions. 1% by volume. Xenon and radon are the rare elements. Radon mostly available in the form of radioactive decay of xenon, mostly available in radioactive decay of radon. Okay, radioactive decay of radon. This is atomic number is 88, mass number is 226. If it is going to be decomposed, then radon going to be obtained. Okay, this its atomic number is 86 and it is 222. Okay, it is what? 222 mass number. And the remaining one is 2 moles of, not 2 moles, 2He4, 1 mole of helium would be available. Okay, this is the radioactive decay of radon. Okay, radon would be available. Okay, then next one, this is the general availability and the general occurrence of noble gases. If you go to next one, their physical properties. Okay, first you note all these points, everyone. Yes. Next one is physical properties of all these elements. The physical properties, if you check, atomic mass, physical properties. Listen, before that atomic mass, you need to identify their electronic configuration. Electronic configuration, general electronic configuration, I already told you that is Ns2 or Np6. If you except helium, remaining all are having the same Ns2 Np6 configuration. Helium has duplet configuration. Helium has duplet configuration, that is Ns2, nothing but 1s2 configuration. Okay, remaining all elements are having Ns2 Np6 configuration. Suppose you can check neon, it is the nearest noble gas to the neon is helium, and then 2s2, 2p, 6. Neon's atomic number is how much? 10. Okay, after that argon. Argon's atomic number is 18. Here nearest noble gas is neon, and then 3s2, 3p, 6. Okay, and then here left side, right side I'm writing. Okay. The next one is krypton. Krypton's atomic number is how much? 36. Here the nearest noble gas is argon, 4s2, 4p6, and 3d10. Okay. Next one is xenon. Xenon's atomic number is how much? 54. 54. Here the nearest noble gas is krypton, 5s2, 5p6, 4d10. Okay. Radon's atomic number is how much? 86. 86. So here the nearest noble gas is xenon. Xenon 6s2, 6p, 6, 5d, 10, 4f, 14. Okay. And the next one is after radon, what is that? Ogneson. Ogneson is the next element. Ogneson's atomic number is 118. OZ. This is its atomic number is 118. Its nearest noble gas is R and radon. So here it is a 7s2, 7p6. Okay. Next 6d, 10, 5f, 14. These are all the complete electronic configurations of noble gases. If you check their outer electronic configuration, here it is 6. 4s2, 4p6 for krypton, 5s2, 5p6 for xenon, 6s2, 6p6 for radon, and also then after Ogneson 7s2, 7p6. Dear students, all of you, am I audible and am I visible clearly or not? Please let me know. Yesterday also for a few minutes it was disturbance was happened, so that's what I'm asking again. I'm going to next page. Just let me know yes or no. Yes, it's visible. Thank you, Ma. Thank you. Yes, I'm going to next page. Is it finished, all of you? If anyone is missing, just take a screenshot or okay. Yes, I'm going to next page. In that physical properties, the next one is atomic size. Atomic size. What about atomic size, my dears? Atomic size is here increases down the group. Atomic size increases. Atomic size increases. That means helium less than neon, less than argon, krypton, xenon. Understand all of you? Yes. Next one is ionization enthalpy. Ionization enthalpy. Ionization enthalpy decreases or increases down the group. Actually, we are not going to observe ionization enthalpy values here, but for under experimental conditions, we can able to observe under a decreases. Atomic size not decreases. You are saying about ionization enthalpy? Yes, ionization enthalpy. Lalita said decreases, ma'am. Yes, ionization enthalpy would be decreases. If you, I mean, if you are saying that answer in the view of ionization enthalpy, that is correct only. Okay, helium greater than neon, greater than argon, greater than krypton, greater than xenon, my dears. Okay, so next one is what? Next one is electron gain enthalpy. EGE. EGE is nothing but electron gain enthalpy. Here we are going to observe positive electron gain enthalpy values are observed because here, I mean, no, they don't have to take electron from outside because those are all having completely filled configuration in their outermost shell. That's what we are going to observe positive electron gain enthalpy values. Positive electron gain enthalpy values, my dears. Enthalpy values. Clear all of you? Yes. So next one is what? Electronegativity. Electro En. En means electronegativity. Electronegativity decreases or increases down the group. Electronegativity decreases down the group. Same just like ionization enthalpy. Electronegativity decreases. The same order you can write here. Say this one, ionization enthalpy. So I'm not writing writing that one again. Okay, you just try to understand. Next one is what? After electronegativity, MP and BP. MP and BP. It is not. You already know. Okay, it is only melting point and boiling point. Melting and boiling points are increases down the group. Melting and boiling points are increases down the group. This order, say, increases atomic size. The same order you can write here also. Okay, increases down the group. If you check helium, helium has very less boiling point, that is 4.2 Kelvin. So because of this one, helium used in plastic industry. Which one? Plastic industry, that is polythene making and also glasses making, like that. Okay, and also all these noble because of their low melting and boiling points, these are all having diffusing property. Diffusing property. Clear all of you? Yes. Next one, density. If you check their density increases down the group. Density increases down the group. Okay, and the next one is atmospheric abundance. Atmospheric abundance also decreases. Atmospheric abundance decreases down the group. Atmospheric abundance. This is decreases down the group. Please note all of you, I'm going to next page. Yes, I'm going to next page. Chemical properties, we are going to discuss chemical properties of noble gases. Listen, by observing nearest ionization enthalpy values for oxygen and xenon. Oxygen and xenon have nearest, similar ionization enthalpy values. Oxygen and xenon have similar ionization enthalpy values. That is the reason University of Columbia, in that one, the scientist Niels Bartlett, okay, he prepared one compound that compound has red in color. So by using oxygen, O2 PTF6. This is the red color compound. Niels Bartlett prepared this compound in University of Columbia based on their nearest noble gases, nothing but similar noble gases, similar ionization enthalpy values for oxygen and xenon. So he made this compound. Based on this, this result, he just used instead of oxygen, xenon and XePtF6. XePtF6 minus. So he made this compound at that time in that laboratory. So by using this information, he made one conclusion, that is xenon can able to react with the most electronegative elements. Xenon can able to react with the most electronegative elements. Okay, those are especially oxygen and fluorine. So xenon can form oxides, oxyfluorides, and also fluorides. Oxides, oxyfluorides and fluorides. Okay. So next one. Here, if you go to see their, check its chemical reactions. Xenon reacting with fluorine at 673 Kelvin temperature and 1 bar pressure. So it will produce XeF2. XeF2, xenon difluoride. It is having linear in shape. Okay, it is having linear in shape. Next, xenon reacting with again fluorine at 773 Kelvin. Not 773, 873 Kelvin. This is 873 Kelvin at 7 bar pressure. Okay, so xenon tetrafluoride would be formed, and then after xenon reacting with 3 moles of fluorine at 573 Kelvin, 60 to 70 bar pressure here, my dears. Okay, so XeF6 would be formed. Okay, XeF6 would be formed, and after that the complete hydrolysis of xenon tetrafluoride, complete hydrolysis of xenon tetrafluoride will gives you xenon oxide. So here see 2 moles of XeO3 plus next 24 moles of HF, and then 4 moles of Xe, and then after remaining one is 3 moles of oxygen. Okay, yes, this is the complete hydrolysis, and also XeF6 reacting with 3 moles of water, it will form xenon trioxide, XeO3, and 6 moles of HF. These two reactions are complete hydrolysis of xenon. Next one, and then I'm going to next page. Okay, yes. Next, partial hydrolysis of xenon hexafluoride will form XeOF4 plus 2 moles of HF, and also partial hydrolysis of XeF6 will gives you XeO2 F2. Okay, here 4 moles of HF would be formed. These are the complete hydrolysis of xenon fluorides and partial hydrolysis of xenon fluorides, and also xenon fluorides reacting with fluoride acceptors PF5. Okay, then cationic complexes will be formed XeF plus and PF6 minus. PF6 minus. Okay, yes. Next one, XeF4 reacting with SbF5, then you will get XeF3 plus and SbF6 minus. Clear all of you? Next one, XeF6 reacting with MF, metal fluoride. Here metal fluoride is the fluoride ion donor. So XeF7 minus M plus. Here the metal is sodium, potassium, rubidium, or maybe cesium. Okay, just note all of you, if possible, take a screenshot because very last time to finish this class. Okay, I'm going to next page. Everyone, is it okay? Yes. So we are going to check their structures. If you check XeF2, xenon difluoride, it is linear shape with 3 lone pair of electrons. Okay, you can check its structure. This is fluorine and this is fluorine. These are the lone pair of electrons, 3 lone pair of electrons. Here its hybridization is sp3d hybridization. Its hybridization is what, my dears? sp3d hybridization. Okay, next if you go to XeF4, it is a square planar structure. Okay, shape, square planar shape. You can check its structure. This is Xe, this is fluorine, and this is also fluorine. My dears, please write along with me because the meeting would be end. So this is a lone pair of electron and this is also lone pair of electron. Here it is having sp3 D2 hybridization. And the next one is XeF6. XeF6 is distorted octahedral. Distorted octahedral, you can write complete sentence, okay? Here it is sp3d3 hybridization. sp3d3 hybridization. If you check its structure, it is a distorted octahedral. My dears, the meeting will be end within a few minutes, so please follow with me. You just write with me, okay? I don't have time to give to write, okay? So this is a distorted octahedral. And the next one is XeO3. XeO3 is the sp3 hybridization and also planar shape, okay? Planar means if that is a one lone pair, if you consider that is pyramidal, if it will comes under as a pyramidal shape. Double bond O, double bond O, double bond O, okay? Next one Xe O F4. This is lone pair. This is double bond O. Okay, this is F. This is F. This is F. And this is F. What is its, structure? The structure is nothing but here shape. Square pyramidal. Its shape is square pyramidal. Its hybridization is sp3d2 hybridization. Clear all of you? These are all important important physical properties and chemical properties and general introduction of group 80 elements. I think you are all understand about this complete lesson clearly. And one more important point is here, this XeO3 is the explosive solid. Explosive solid. This XeOF4 is the volatile, colorless liquid. Volatile, colorless liquid. This XeO3 is the colorless explosive solid. Okay, I think it is only 1 minute is there, 1 minute 30 seconds, 28 seconds is there. Okay, and also one more important point, all noble gases are colorless, odorless, tasteless gases. Remember, okay, I didn't mention that point, that's why I just tell it that one. Okay, if it this page is finished, then I just want to show previous pages. Yes, I'm going to previous page. Only 1 minute is there. Maximum I'm trying to cover complete chapter within 35 minutes. So I hope you all get complete information about this chapter. Okay, students, I think meeting would be end within few seconds. So try to understand about this lesson completely at home by reading. Okay, we will see in tomorrow's class.